Hello everyone. So we were seeing the demo of this last video where we are supposed to switch on each and every LED one after another with 400 millisecond delay. Then we have to switch off everything together. We have to switch off everything together, and then again we have to switch on from first to fifth, and we have to repeat. Okay. So we were doing a demo and we found there is an issue. So let's have a look again. So this is our demo. Let's start it and see. So first LED is on, second LED on, third LED, fourth LED, fifth LED. Again repeatedly on. Okay. You see, even all the LEDs are on, they are going off suddenly. Okay. But the first LED is not going off. You see this? See, look at the first LED. It is not going off after first iteration. So there's some problem, right? First I will change the delay time. It looks so fast to me. Okay. Then we have to find out why the first LED is not going off. Something wrong with our code, obviously. Okay, so we'll check. Okay, so let's see how I'm going to refactor this code, guys. Debug, the troubleshoot this code. Okay, first I will increase the delay to 500 milliseconds. This is fast because depending on this simulation, because it's simulation environment, so the time delay may change. Even if we give 400 or 500, that if the environment is fast, it will be perfect. Or 500. It is slow, the time will be more than 500. So in the real Arduino, if you give 500 milliseconds, this is exactly 500 milliseconds. If this is 400 milliseconds, it's like exactly 400 milliseconds. Okay, so just don't worry about that. Now I will see how these LEDs are going to be on. Okay, so let's see. In the first iteration, LED first in the pin number 3 will be on. First LED. Okay, second LED is on. Okay, I'm writing the pin numbers. Okay, third LED is on, fourth LED on, fifth LED is on. Okay, these will happen one after another in 500 milliseconds. That's undoubtedly true. Okay, that's so true. Okay, when the seventh LED is on, there will be a 500 millisecond delay. Okay, that's okay, and I become 8, and for loop will come out of this. Code will come out of this for loop because of the condition is false, and we'll come to line number 16. Okay, so now we are in the line number 16, right? That's good. Line number 16. At the time, all these 5 LEDs will be on. Okay, and the last LED have made on, and 500 millisecond also passed, and the code is at the line number 16. Is that clear? Okay, the issue is with the first LED, right? We know, because the first LED is the one that didn't switch off during our simulation. Now I have stopped the simulation. During our simulation, the first LED is the one that didn't go off. If you don't understand, you can go back in the video and see the simulation. Okay, so this is the issue. So issue is here. Okay, so this particular LED and all the 5 LEDs are on, undoubtedly. Okay, that's fine. So then we come to line number 17, and during each and every iteration, we switch off every LEDs. Okay, 3, 4, 5, 6, and 7. We switched everything off. There's no question on that. Okay. One after another, but at no time we did, because there is no manual delays given. So at 0 time, this for loop have finished iterating, and all the LEDs are on. Off. All the LEDs are off now. Okay. Here when we are in the line number 16, everything is on. We are in the line number 18, everything is off. Okay. Wait. Now the for loop will become broken because I became 8 now, because I value is 7 plus 1, 8. Okay, when the last LED is off, okay, when the last LED is off, I is 8, I is incremented 8, so this is false. We come out, this is false, so we come out of the for loop. We come to the line number 20, we come to line number 21, we come to line number 9, and we start the void loop, and we come to line number 11, we take integer I, and line number 12, we start the for loop, and again we switch on the first LED, remember. Okay, and again we switch on the first LED. Which LED? First LED. What is the first LED? LED number 3. Okay, then we take a 500 millisecond delay, and we come here, and again we switch on the next LED, and we do so on. Okay, now consider the first LED only. Okay, look at this. Okay, there's no question at the first void loop scenario. Okay, at the first void loop iteration, void loop. Okay, we switched on all the LEDs one after another, so we don't worry. Okay, because all the LEDs are on, that functionality is not broken. Okay, let's say when we come here, line number 16, the time, let's take the time. Okay, time is, let's say, it cannot be 0 seconds. Let's say, I'm just saying, let's say 15 seconds, the time from the starting. I'm just saying, okay, it's not true, just starting, just saying. Okay, so now, okay, because let's say let's come from the beginning, so that's enough, easy. Okay, let's say here when the starting time, this is t is equal to 0, time is equal to 0. Okay, just follow me up, you'll get it. In the for loop we have 500 millisecond delay in the for loop. So we come here, when we come to the for loop, it is still 0. Why? Because I say it, from one, when we move from one line to another line, we take no time, program takes 0 time. So this is 0, this is also 0 time. If it takes 1 second, this t should be 1. You get it? Okay, because it starts from 0. Now if it takes 1 second to move from one line to another one line, t should be 1. Okay, but that's not true. The program takes 0 time from moving one line to another line. So t should at the line number 20 also t should be 0. No time is taken. But end of the each and every iteration, okay, when every iteration is finishing, we have a manual 500 millisecond delay. Okay, so at the first iteration is finishing, okay, we will have t is equal to 500. So let's say this is in millisecond values. Okay, t was 0 at the initial, but 500 millisecond delay we took, so the new t value is 500. When the second iteration is happening, we took another 500 millisecond delay. So second iteration finished, we again come and check the for loop. At that time, t value is increased by another 500 millisecond. New t value is 1000. Likewise, we will have 5 iteration. Okay, so this will increase. Okay, at the end of the 5th iteration, what will be the t values? 2500 millisecond. Okay, at the end of the iteration, final t value will be 2500 millisecond. So when the iteration starts, end of the first iteration, end of the second iteration, end of the third iteration, end of the fourth iteration, end of the 5th iteration of the for loop, end of the, okay, that means 5th LED also switched on, and we took a delay and we increased the I, and we came here to check and break the for loop. At that time, t is equal to 2500. Do you understand this? Otherwise, rewatch the video and get the idea. Otherwise, you will not understand anything. Okay, when the for loop is breaking, t is equal to 2500. You get it? That's clear, right? Okay, fine. Now, for loop is breaking. Okay, we come out of the for loop and we come to the line number 16. Now, what is the t value? Did we get into the for loop? No. We directly jump from line number 2 to 12 to 16 because this is false. So we jump to 16. So to jump from one line to another line, if there is no delay, because delay is inside the for loop, we didn't get into that. If there is no manual delay, how much time it will take? It will take 0 time. So it will be in the last time when the for loop is checked. So what is the last time value when the for loop is checked and found to be false? This is 2500, because at the end of the 5th iteration only we checked and found it is false and we came out here. So end of the 5th iteration, t is equal to 2500. Do you understand this? Okay, so 5th iteration ending, t is equal to 2500. We check it again because there is no manual delay, because end of the 5th iteration we came here and we check it again. Okay, no manual delays thereafter. After 15, line number 15, there is no manual delay. So we check again and we jump to line number 16. So when we are checking at the end of the 5th iteration, it is 2500. So when we jump here, breaking the for loop, it is still 2500 because no manual delay. So Arduino takes 0 time from moving from this line to immediately this line, skipping everything here. So the time will be still 2500. Do you understand this? If you understand this, hold it on here. I will continue this in the next video.